Hey everybody, this video is on standard form of linear equations, standard form, not to be confused with slope-intercept form. Slope-intercept form is, ironically, the most common form of expressing a linear equation, and slope-intercept form is called slope-intercept because it includes m, the slope, and b, the y-intercept, which are two very convenient landmarks that allows you to quickly graph an equation in this form. Equations that are in standard form take a little bit longer to graph, but they too can be graphed quickly. An equation in slope-intercept form looks different than one in standard form. In standard form, it might be, for example, 2x plus 3y equals 12. In standard form, the landmarks are a, the coefficient of x, b, the coefficient of y, and c, a constant amount, a constant sum or difference. You might want to make a note of that. A, b, and c will all be integers when the equation is properly shown in standard form. Standard form is often used when you have two things that will add up to 12, and there are multiple combinations of x and y values that can produce a sum of 12. Similarly, it'll be used if you have two things when you have a difference of 12 or any other number. These two things, when subtracted, will produce a difference of 12. Above are two equations which appear initially to be in standard form. However, they are not in standard form because a, b, and c are not all integers. In the first one, a is 1/2, b would be 1, c would be 10. This is fine. There's a 1 there, even though you can't see it. It's 1y. This is the issue, the 1/2. To clear that 1/2 out, you would multiply both sides of the equation by 2, because 2 will clear the fraction of 1/2. After the multiplication, you'll have 2 times 1/2, just 1x, 2 times y plus 2y, 2 times 10 equals 20. This is in standard form. The value of a is 1, the value of b is 2, the value of c is 20. Take a moment and pause this recording and transform the second equation, 3x minus y equals 1/2, into standard form by clearing the fractions and winding up with all integer coefficients. Go ahead, pause the recording. Okay, so hopefully you're able to see that this also had a 1/2 in it. So if you were to multiply both sides by 2, you'll have 2 times 3x, 6x. 2 times negative y will give you negative 2y. 2 times 1/2 will give you 1. Now this equation also is in standard form, where a is 6, b is negative 2, c is equal to 1. The simplest and most accurate way to graph a line that is in standard form is to quickly figure out the intercepts. You recall, the intercepts are always going to be when the x-coordinate is 0. In that case, you will be on the y-intercept. And when the y-coordinate is 0, in that case, you will be on the x-intercept. By substituting in the value of 0, you'll have 2 times 0 plus 3y equals 12. Therefore, 3y equals 12. Therefore, y equals 4. 0, 4 is 1 point. do the same for the y. So you will have 2x plus 3 times 0 plus equals 12. And therefore 2x equals 12. X then equals 6. The point 6, 0 is the other intercept. At this point, you can go ahead and quickly graph over 0 up 4 and over 6 up 0, and then carefully draw the line which shows all possible solutions. I suggest drawing it more carefully than I'm able to on this video. Okay, in a minute, pause your video and graph the equation of x plus 3y equals 9 by first finding the x and y intercept, then plotting the points, and drawing the line that shows all possible solutions. Go ahead and pause now. Okay, so hopefully you were able to graph that by putting out the intercepts. The intercept's 0, 3, right there, and the intercept 9, 0. If you notice, when you're drawing the line, you want to make sure you're drawing the line. I haven't drawn it in here, but the line shows all the possible solutions. One connection that occurs with slope-intercept is when you transform from standard into slope-intercept. It's another way to make the connection between the two forms. It's also a quick way to graph if you don't like doing this method right here. So another way to graph an equation in standard form is to use your knowledge of transforming equations in order to get an equivalent equation in slope-intercept form. Simply solve for y. So to solve for y, you want to get rid of this x, subtract that from both sides. You will then have 3y equals negative x plus 9. It's not quite in slope-intercept form. You need this solved for y. So you're going to have to divide by 3, divide everything by 3, divide everything by 3. That gives you y equals, well, dividing by 3 is the same as multiplying by 1/3. So that gives you 1/3 negative times x plus 3. So when you go to graph that, you notice here's your y-intercept, 3. Okay, and the slope is negative 1/3, which means you'll be headed out here, just like in the graph on the previous page. So you have your choice. You can simply say, well, if x is 0, what's y going to be? 3. If y is 0, what's x going to be? 9. Plot those points, 0, 3, 9, 0, and draw the line. Or transform the standard form into slope-intercept form and plot it in that manner. Here's an example of a line in slope-intercept form. Transform it into standard form. Pause the recording and give it a go. Okay, so hopefully you were able to see that you needed to get this 1/2 x on the other side of the equation, which will give you negative 1/2 x plus y equals negative 5. Now you're close here, but you're not quite in standard form because, again, of the fraction. So you see in the denominator that the fraction is 2. It's not always going to be 2. I've been using 2 in this example, in this video. Times 2 times 2, so negative x plus 2y equals negative 10. Now you're in standard form. Okay, and for your last little bit of homework, we have 2 problems. On the first one, you need to transform y equals mx plus b form in this problem right here into standard form. So transform this into standard form. Make sure you have all coefficients for a, b, and c. figure out what are the y-intercepts and the x-intercepts. Might want to do that with the standard form that you found. And graph all your solutions. You can graph your solutions using the x-y coordinates, or you can graph it by looking and saying, oh, here's the slope and here's the y-intercept. Similarly, in the second one, transform this equation into slope-intercept. Make sure you give all your x, y coordinates for the intercepts, and go ahead and graph that line, whatever it may be. You can do it with the intercepts, you can do it with the slope-intercept form that you found. Okay, that's it, and we'll see you soon.